JEE Main 2026, Question 50. Archimedes principle, floating wooden cube with a cone. Finding the mass of a metal cone placed on a floating wooden cube using Archimedes principle. Let us visualize the problem. We have a tub filled with water. A wooden cube of 10 centimeters on each side floats in the water. Initially, 4 centimeters of the cube is submerged and 6 centimeters is above the waterline. When a metal cone is placed on top of the cube sinks further by 3.87 centimeters, making the submerged depth 7.87 centimeters. The question states, a wooden cube of 10 centimeters on each side, with wood density 0.4 grams per cubic centimeter, floats in water of density 1 gram per cubic centimeter. A metal cone is placed on the cube, and the submerged depth increases by 3.87 centimeters. Find the mass of the metal cone in grams. Key concept, Archimedes' principle states that the buoyant force equals the weight of water displaced. For a floating body, buoyant force equals total weight. When extra weight is added to a floating body, the extra sinking provides extra buoyancy equal to that extra weight. So the mass of coin equals base area times extra depth times water density. Step 1. Find the mass and base area of the wooden cube. Volume equals 10 times 10 times 10 equals 1000 cubic centimeters. Mass of cube equals 1000 times 0.4 equals 400 grams. Base area A equals 10 times 10 equals 100 square centimeters. Step 2. Verify initial floating. Initial submerged depth equals mass of cube divided by base area times water density, that is 400 over 100 equals 4 centimeters. This confirms the setup. Step 3. When the cone is placed, the extra buoyant force equals the weight of cone. Extra buoyancy equals base area times extra depth times water density. That is 100 times 3.87 times 1 equals 387 grams. Therefore, the mass of the cone is 387 grams. The answer is, mass of coin equals 387 grams. G-tip, when extra weight is added to a floating body, the increase in displaced volume times fluid density equals the extra weight. The quick formula is change in mass equals base area times change in depth times fluid density. This works because the floating equilibrium shifts so that extra buoyancy exactly equals extra weight. Also verify the initial floating condition to confirm the problem setup. Like and subscribe for JEE Main solutions at MAGPIEHUB.